In this video, I thought I would just hit some of the highlights in the reading. One of the things that I wanted to point out for you was a connection between the 4 basic conditional arguments and a few things that you learned in previous units in your reading. All right, so there's a connection, first of all, to the various forms of conditional statements. If you remember, we talked about the converse, the inverse, and the contrapositive. All right, so we have 4 basic conditional arguments here. 2 are valid and 2 are invalid. All right, and if you look at the first one, this takes the form if P then Q, right? And then the second 2 premises are P is true. The second premise is P is true, and the conclusion then is that Q is true. Right? So if you kind of rewrite this second piece here as an if-then, right? So we can do that because this second piece, P is true, that's going to be a premise. So what we're saying is that if P is true, then we can conclude that Q is true. Right? So if you look at that as a pair of sentences, right? The first one is if P then Q, right? And then the second is if P then Q. All right? So that's just the original statement. That's just the conditional. So I would say this is perhaps the simplest or easiest to see that this is valid, because it's really just kind of restating the original sentence, right? If P then Q, we know P, so then we know Q. Now if you look at the second one, if P then Q, and then do the same thing by taking the second premise and the conclusion and making an if-then sentence out of that, right? Then we're saying this argument is concluding that if Q is true, then P is true, right? And that's invalid. That's not actually a logical conclusion there, right? But if you look at the second statement, how does that relate to the original conditional? Well, the original was if P then Q, and this one is if Q then P, right? So that should look a little bit familiar. That's just the converse of the original statement, right? If Q then P is the converse of if P then Q. And we learned before that the converse and the original conditional are not necessarily logically equivalent, and I would say I hate to say most, but in many cases those actually are saying opposite things. They're not the same, right? So it makes sense that that one would be invalid. The third argument here, denying the hypothesis, the original statement again is if P then Q, and the second premise and the conclusion could be rewritten as if not P, okay, because that's if P is not true, okay, then Q is not true, so not Q. Well, what form is that? Well, that's just the inverse of the original statement. So it kind of makes sense why that would be invalid as well. We know that the inverse of a statement doesn't necessarily say the same thing as the original statement. And finally, if you look at the last one, we have if P then Q, and then the second piece can be rewritten as if not Q, then not P. And you learned that that's the contrapositive of the original statement. Right? And when you did truth tables for this, we found that the contrapositive of a statement is logically equivalent to the original conditional. So it kind of makes sense that these two would be valid because they're logically of the same form, and it makes sense that the converse and inverse would be invalid because those are, not logically equivalent to the original statement. So this also gives you a connection to some different names for these arguments. The first one, right, is just the original conditional, and you've got here the Latin term for that, modus ponens. Right. The last one, you've got the Latin term modus tollens, but that one also is sometimes called the law of contraposition, which makes sense if you see the connection to the contrapositive of that statement. The 2 in the middle are invalid, so those are fallacies, and the first one is often called the fallacy of the converse, and you can see why. And the second one is often called the fallacy of the inverse, and you can see why. All right, so from this section, I hope one of the main ideas that you saw here is how to test or evaluate arguments to see if they're good ones or not. Right? So two of the things we're looking for would be tests for validity and then also tests for truth. Right? So the second one, to test if something is true, involves fact checking, and you learned earlier in your reading some different ways to do that. The new tests in this section deal more with the validity of an argument or with its logical structure. Right? So you have one nice test, which is Venn diagrams. Right? And your reading was fairly clear with this. They gave you quite a few examples of how to do that. Right? And then I just wanted to make sure you caught the second way to test the validity of an argument, and that is to actually look at those four common structures. Right? And then you had actually one more later on in the reading. But if you get used to the structure of some of these common ones, right, if you can recognize that something is this affirming the hypothesis thing, right, then you don't necessarily need to make a Venn diagram every time if you can see that that takes on a valid form. Right? Similarly, you may see the fallacy of the inverse or the converse, right? And as you get used to recognizing these common fallacy forms, then you can pick it out from just the way that things are phrased. What I thought I would do too is to look at examples 9 and 10 from your reading, and one of these is valid and one is invalid, and I thought we could make Venn diagrams for these and do that test just to see that one is valid and one is not. Right, so for example 9, here are the premises and conclusion, and the original example was worded differently, but the first step is to try to rewrite this in this sort of if-then type format here. And once you've kind of rearranged this into more standard forms for the propositions, then we can go ahead and put together a Venn diagram. All right, so let's put some labels on these things. So we have, if Maria Lopez is elected to the school board. Right, so that's our first statement, so let's call this P. Let me use a different color. Okay, that's P. Then the school district will raise academic standards. Right, so that's a different statement than Maria Lopez is elected, so we'll call it a different letter, and just going in order alphabetically, we can call that Q. Okay, and then in the next premise, if the school district raises academic standards, right, so that's saying the same thing as the previous Q, so I'm going to label that Q again as well, then my children will benefit. Right, that's a new statement, so let's call that one a new letter, and we'll choose R. So now the conclusion is, if Maria Lopez is elected, that's P, okay, then my children will benefit, that's R. Right, so here's the structure. We're saying if P, then Q, right, and if Q, then R, and then our conclusion is if P, then R. And your book states that this is like a chain of conditionals, and if you can see the chain, then you can see maybe that this is valid. Right, so P leads to Q, and Q leads to R. So if we start with P, it sets off this little chain of reasoning things. P causes Q, which causes R. Right, so we can kind of skip that middleman Q and just say starting with P is eventually going to lead us to R. Okay. So that's one way to do it if you can kind of reason through the validity that way. And then the other way to do this is to look at a Venn diagram. Right, so we'll start with that. And we know that if P then Q, right, has a connection to those categorical propositions, so we could also think of that as saying all P are Q, right, or if something is belonging to that set P, then it's belonging to the set Q. So we want to make this like P is a subset within Q. All right, and then the second statement is saying if Q then R, right, or all Q are in R. Right, so that's saying that Q is a subset of R. All right, so I'll put a bigger circle around Q, and that way Q is a subset within R. Okay, and then our conclusion. If something is in P, or in the case where P is true, then that means that R is true. So let's use an X now, and let's place something in P, right? And then we just want to see if this statement is true. It does. If something is in P, is it in R, or can we say that all P are in R? And yes, so if you kind of, in this case, if you ignore Q here, right, and just look at the relationship between P and R, okay, that's exactly what we've drawn. Right? We've drawn P as a subset of R. So this is the Venn diagram test to see that this is valid. All right, example 10 gives an invalid chain of conditionals. All right, so you've got your original argument in words. We agreed that if you shop, I make dinner. We also agreed that if you take out the trash, I make dinner. Therefore, if you shop, you should also take out the trash. Right, so let's choose some letters here. So P can be you shop, Q can be I make dinner, and R can be you take out the trash. And then we've got this if-then form. We have if P then Q, if R then Q, and then can we conclude that if P then R? So same thing with a Venn diagram. And you may actually already hear that this is not valid. All right, so let's start out with if P then Q. So we have P is a subset within Q. Right, and then if R then Q, right, and then here it's slightly unclear where exactly I should draw R. Right, so I know that it should be within Q, right, a subset of Q, but should I draw it inside P? Right, should I draw it outside of P, or should I draw it overlapping with P? All right, so it's kind of unclear if these are disjoint sets or one is a subset of the other. All right, so right now I'll do one that's overlapped, since I don't know, and we'll call that R. All right, and then for our conclusion, if something is in P, then is that in R? Right, so where should we place the X? Okay, well there are a couple different options here. I could place, there could be an X that's in P but outside of R, right? Or it could be within P and within R, right? And it's not really clear, so I kind of need to put that X right on the border there, right? So this is not necessarily true. If something is in P, it doesn't have to be in R. There is another option. Okay, so because that's kind of unclear or ambiguous there, then this is not a valid argument. This one is invalid. All right, so this gives you one more example of a fallacy. Right, so if you see this, if you can rewrite your argument in this form, if P then Q, if R then Q, if P then R, right, then that's not valid. That's a fallacy. Right, or here's another example that you can add to your catalog of valid ones. Right, if P then Q, if Q then R, if P then R. Okay. In addition to that, you can actually just continue that chain as long as you want. Right, so I can say if P then Q, if Q then R, if R then S, if S then T, and you get the idea. You can do that as much as you want, and then it's valid to say that if P, right, then P leads to Q, which leads to R, which leads to S, which leads to T. So ultimately, if P, then T. So anything that takes that form is valid.